Okay, so apparently I'm streaming now. Close that. There should be no chat. My cat is being weird. Anyways. Hooray. Okay, so yeah. I'm going to start on chapter 3, I guess. And that's page number 38, 39. It does the hello world. Sure. Let's just work with it and work through it. Pull out a stapler here to hold the book down on one side, lay flat my butt. Holy cramps, it won't lift, maybe. Nope, no good. Craps. Wait. Deck box. Oh, we got it. 2 deck boxes. All right. So let's start by making this, and we start with chapter 3. Inside this, we're going to start with a hello world.py. And then, yeah, it's just a simple print. Hello world. Oops. Hello world. Okay. So that's fine. Let's hit that. There. Boom. Okay. Yay, it ran. Next page. There's nothing novel here. Yeah, so far there's nothing different than the CS, but you know what? I haven't touched this in a long time, and I'm just gonna continue on with it. Oh, and I did. Did I do the right one? Oh, that was a hello world.py. Okay. Now it's asking for another one that's going to be hello input.py. And that is just going to be name equals input. What's your name? And then we're going to have the print hello. Then we're going to concatenate on name. And then we just hit the print. Oh, it's waiting for name. I can't input shit here. This is fucking bullshit. Like, I don't understand. Code is already running. There's nothing can't type shit here. Thanks, guys. It doesn't do shit. Okay. I don't get it. I'm not gonna fuck with it. Dead simple Python. we're gonna change directory to chapter 3. Nope. We normally do a make directory. Change directory, is that an option? No. Okay, so yeah, let's start figuring this out. Change directory. Oh, I gotta remove spaces in the name. Oh, that's what I'm looking for. Jesus Christ. Yeah, you have to add quotes in order to go to there. So now let's just do Python hello underscore input dot py, and then we can type in Jeremy, and then it'll say hello Jeremy. Okay, so problem with that is that this needed a space behind it. Okay, right. So now that I'm also there, the section code evaluates a single colon expression. So then now we're starting another one. So we're gonna say code hello underscore statements dot py dot colon 1a. What is... Huh. Interesting. You guys can't see this, but it opened up another window. It doesn't make any sense. And it didn't make anything. Okay. So I'm gonna just go message equals hello world. Then we're gonna hit print. Message. And then that's gonna say hello world. Okay, yeah. Oh, do I need to... I guess I need to do that. I really don't care. Code with Jeremy. copy from default. Oh, Jesus Christ, what the fuck's going on here? Sure. It looks like all my things is too small. Settings. Font size. 22. Better. Let's just go 24. And then we need to find auto save. Right, so auto save after X amount of settings after I actually save the whole thing. So we hit the save, and now it's just going to auto save every every 1,000 milliseconds. Okay, and then we can actually just go back down to here and hit Python hello underscore statements dot py, and it just says hello world. Perfect. Okay. Now, saying that in, so we can take this and we can just cut that out, comment that out, and then we'll do it again. We'll go message equals hello world, and then it's saying that we can hit just a colon and then hit print message. I think that, did I say that that's how it's done? Yeah. Okay, and then we can go control tilde. We can just hit the up arrow, hit that, and it'll still say hello world, but we just capitalized it instead. Okay. Okay, and now we're on to the importance of white space. Okay. So again, we go code hello underscore conditional as far as, yeah, no chat, nobody's watching, it's fine. So then, oops, my brain was worried that there was a window yeah, there's a window missing in thing there. All right, no chat. I'm always worried that actually somebody would be watching. We can close that. We don't need that. Okay. So again, because I don't do this very often, conditional .py. Is that I need to spell things correctly, and that's the answer. Okay, we're just gonna hit save right away. We don't need to really worry about that. Now we've got name is equal to JSON. Now, if name is not equal to blank, then message is equal to hello plus name plus exclamation point, and then we're going to print message, and then if nothing else, oh yeah, that's the full thing. We're just going to print I am a computer, period. So now it's already automatically saved, so I don't need to worry about that because it's going to do it after every 10 seconds. It's going to save, so it shouldn't be a problem. So we're going to say hello. We're not going to code hello. We're going to hit Python hello conditional .py. Hello, Jason. I am a computer. Okay. And then if we come back into the code and we remove this, it should just print out I am a computer. Correct, because we did not fill out the first part. Okay. And now we're weather nested. Oh shit. Code weather nested conditional.py. Okay. Hit save. And then it's saying raining is equal to true, which we don't need to put in quotes because it's a Boolean. Hailing equal to false. We always try to have a space in there, so if raining and if hailing, nope. Print, nope. Else we're gonna print I don't like that print, but it is what it is. I'll leave it because maybe one day I'll actually have to use it like that. Umbrella time. Okay, so we're using PEP 8 according to the book. I'm lazy. It's umbrella time. Okay, let's flip flip this. And we'll flip this to true. Come back down, do this, conditional. It came back with nothing. Okay. Why did it come? Oh, because raining wasn't true, so it has to be, both parts have to be true in order for it to trigger. In this particular case, because if raining is true, then nope. Okay. All right. Because I have an issue with that, but whatever. I don't care. Give a shit. Because it's not always hailing if it's not always raining if it's hailing. Okay. If you ever need to pack a conditional statement or something similar into one line, you can omit both the line break and the indentation. As an example, if raining print umbrella time. The colon serves as a separator. However, as a semicolon from earlier, be mindful of the effects it can have on readability. Okay. Okay. We're going by pretty quick. Alright, next we are doing code raining pass. Okay. And then this just says raining equal true. If raining is equal to true. If raining pass. Okay, wait. Well, on occasion, you need to insert a statement that has absolutely no effect. This is particularly useful when you need to put in a syntactically valid placeholder where a suite of code will exist later. For the purposes of Python, for this purpose, Python provides the pass keyword. For example, I can employ the pass keyword as a placeholder in my if raining condition until I am able to write the final code. Just remember, pass does absolutely nothing. That is the only reason it exists. Okay. Okay, well, I mean, that's... So if it does absolutely nothing, then if we were to hit... if we go Python raining pass, then it should just kick me right out. Yeah, it kicks me right out. It runs through it all and then kicks me out. Okay, so next we're going to hit code comments.py. This one's going to be super simple as usual, because like this is a comment. Print hello world. And then we're gonna print hello. Oh. How are This is a comment. Oh, this is an inline comment. And then we're going to say, here is another comment. And another. And you get the idea. And yeah, we'll just run this. What is it called? Comments.py. Yep. Okay. Oh. Ow. Okay. And then now we're going to do another one. It's going to be code docstrings. And we're defining make t. We're defining a function called make t, and then we're generating a docstring. We'll produce a concoction almost, but not entirely. Oops. Oh, unlike t period. Enter. Ellipses. Function logic. Okay. Yeah, and define a function that would theoretically make t, and I place a description of the function inside the docstring. Docstring exist to provide documentation for functions, classes, and modules, especially public ones. They conventionally begin and end with 3 quotation marks, allowing the string to automatically span multiple lines. You would typically place docstrings at the top inside of whatever it is you're defining, such as in the function above. There are 3 important distinctions between comments and docstrings. Number 1, docstrings are string literals. They are seen by the interpreter. Comments are ignored. Docstrings are used in automatic documentation generation. Docstrings generally only Number 3, docstrings are generally only docstrings when they appear at the top of the module, function, class, or method they define. Comments can live anywhere. It is perfectly possible to use a triple quoted string literal to write a sort of multi-line comment, but it is not recommended, since a string literal can easily get left in place where Python will try to use it as a value. In short, use docstrings as intended and stick with comments for everything else. Many Python IDEs have hotkeys for toggling comments on a section and can save you a lot of time. I can access these docstrings later in my code. For instance, given the previous example, I can do this. Okay. Okay, how does this work? Print make t dot dunder doc help make tea. Okay, so let's see what happens when I go Python. Oh, I haven't even saved. Go back up to here. Go to save. Okay. Now we'll go back down here. Python docstrings.py. It did nothing. Maybe because this is in the wrong section. Okay, let's try this again. Up, docstrings. Okay. Ah, okay, yeah, alright. Okay. Yeah, alright, that makes sense. Okay, so if I use the help and then try to find the function, it'll print it, showing me the function that's there. If I just do print dunder doc, then it'll just print that but not tell me the whole thing. Okay, and then what if I just move this over to here? Oh no, it does that there. It prints exactly as is there. Okay. Alright. I see. Declaring variables. Okay. It's called code variables.py. We'll hit save just to get it taken care of, so we don't need to worry about it. And then we say name is equal to JSON. Name is equal to JSON. Points is equal to 4571. If we hit save, it does not do a formatter. Prettier. Oh my goodness. Back to here. Oh, okay. Open logs. Okay, I guess I gotta hit this thing to do the prettier. Okay, so we're back to here. Print name, and then we have a comment here that says displays JSON, but not quite like that. Then we have print points. And that's gonna say displays 4571. And now here it's saying that we're gonna change points to 42. I have an extra space there, excuse me. And then we're going to hit print again, and we're going to say points, and it's going to now display .42. And the reason why it does this is because Python goes in order, so it'll see the points at 4571, then it'll print points, and then it'll see the next thing that we changed points to 42, and now it's going to rechange that and now it's going to print out 42. So if we come down here and we hit Python variables.py, hit enter, we see that it is 4571. That is a little small as well. Okay, how can I settings terminal font size? We are going to do this at 24 as well. Much better. Close settings. We don't need all these open. Okay, yeah, much better. Okay. And then what are we gonna do? we got that taken care of. Constants. Python doesn't have formally defined constants. In keeping with PEP 8, you would indicate a variable is intended to be treated as constant by using all caps names with underscores. Naming convention is sometimes humorously referred to as screaming snake case in all caps. Screaming and underscores snakes. For example, the name interest rate in all caps indicates that you don't want the variable to be redefined or changed in any way. While the interpreter itself won't prevent the variable from being modified, your linter will usually complain if you do. Okay. Mathematics, you know, has all sorts of functionality, blah, 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 blah. Computer science. Floating point numbers, yeah. Internally, there are values. Read the article, What Every Computer Scientist Needs to Know About Floating Point Arithmetic. Yeah, it'll go to like 804 or 8 zeros and then a 4. You can specify invalid number with float nan for a number larger than the largest possible value, with float infinite or a number smaller than the positive number, which is negative infinite. Notice I write the special values in quotes as is necessary if you want to use these values without importing the math module. If you import the math module, then see the math module subsection below. You can use the constants nan and so forth instead of quotated versions. Okay, complex numbers. Decimal and fractions are two additional object types for storing numerical data. Decimal stores fixed point decimal numbers, while fraction does the same for fractions. To use either, you need to import them first. Here's a brief example that uses both. Okay, we're still in chapter 3. So code fractions underscore and underscore decimals dot pi. Okay, hit the save. From decimal import decimal from fractions import fraction. Should have a space sitting there, so now it's saying third fraction is equal to fraction 1 comma 3 1 comma space 3. Oh, a third fixed is equal to decimal quote 0.333, and then third float is equal to 1,3. And then we're gonna print third fixed, and we're gonna say and go Alt Shift down, and then Alt Shift down. Third fixed is going to print 0.333. One, two, three. 1, 2, 3. 1, 2, 3. 1, 2, 3. Yeah, that's right. And we're gonna say third float is equal to float third underscore fraction, and then we're gonna print third float, and then we want to print third float is equal to float third fixed. And we're going to hit print third float, and then this should equal to 0.333. Okay. Then we're going to hit Python. Oh, this is going to take forever. Fuck that. Python fractions and decimals, and there we go. Okay. Well, no. That. Oh, whoops. Okay, let's try this again. 1/3 triple three and 1/3 triple threes. 3. Yeah. Okay. Okay. So we're gonna hit clear. Just right back. Then we're gonna do a code operators dot py. Yep. And then we're gonna hit save. And then we're gonna. This is going to take a lot, but it is what it is. Print negative 42. Print absolute negative 42. Let's see what happens. Negative unary value 8 to negative 42. And we're going to call this absolute value 8 to 42. Okay, now we're going to print 40 plus 2. Addition. Evaluates to 42. Print. What are we printing? Print 44 minus 2. This guy loves his Hitchhiker's Guide to the Galaxy. Subtraction. Value needs to 42. Print. Sorry, something in my print times 2. Multiplication. How would I spell things correctly? Evaluates to 42. Print. Divided by 16. Division. Evaluates to 42. New print. This is known as floor division. Discards remainder. Evaluates to 42. Okay, but it doesn't prove anything. Like, I'm sorry, buddy, but that doesn't prove anything. The only reason why it doesn't prove anything is because we know we already know that it's going to have a 0, right? Like, I'll just pull up my calculator real quick here. 16 times 42. Oh, okay. No, 16 times 42 is 672. Okay. Okay. What do I know? Fuck, I gotta do the math. evaluates to 42. Print. Exponents. Evaluates to 42. And then we're going to print once again. And then we're going to hit this bracket again. And we can do our bed moss. Brackets, exponents, multiplication. Yeah. Brackets, exponents, division, multiplication, addition, subtraction. And there we go. Or parentheses, as it is called here. Evaluates to 42. Okay, well, let's give it a shot. $42.5. Where did we get the... Oh, evaluates to 42.5. I was just going through the motions so many times. Wow. Okay. Hey. I love you, kitty, but you can't do that. Okay. Out of here. No. Just trying to give you a little bit of a nudge there, sorry. We'll clear that. And then we're going to hit code augmented assignment operators dot augmented assignment. What a long name, guy. Jeez. Foo is equal to 10. Foo is equal to... Oh. Foo plus 10. So now... value is now 20. 10 plus 10. And then foo minus 5 with the value is now 15 because it should be 20 minus 5. And then foo. So we're going to take the 15. Foo is equal to 16. So now value is now 240 because it'll be 15 times 16. And then we're going to do value is now going to be 48, which is equal to 240 double divided by 5, which we know from math operators is the floor division, so we're discarding the remainder. So if there is any remainder, we're discarding it. And then, which there shouldn't be because it's an even, it's a multiple of 10, so 5 is fine. And we're going to divide that number by 4, which the new value will be 12.0 because it's going to show the decimal place because it's 48 divided by 4, which we know is 12. And then we are going to do exponent to the exponent 2, which is going to be value is 144 because it should be 12 to the exponent 2. It's going to come out at 12. It's still going to show the 0.2 because we haven't set an absolute number. And then foo, we're going to get the remainder of that number of 144 divided by 51, which should be like 2 point something. That is a mistake. So it should be 15 when the value is 42.0. Module 15. Okay. So then we'll come down here. Such a long name. And then we'll hit enter. Oh. Craps. So we need to come to here and we're just going to hit print foo. We're going to hit copy, return paste. Okay, so now let's hit this. So we got 20, 10. So we got 10, 20, 15. Value is now 42. Which one is the mistake here? Okay. Okay. So the comment was the mistake because he had the mistake in there at 15. Which it shouldn't have been a problem. Okay. If you need both floor division and module on the same operands, Python provides the div mod function to effectively perform the calculation, returning the results as a tuple or a tuple. Thus, C equals div mod AB is the same as C is equal to floor division C is equal to A floor division B, comma A module B. Python also has bitwise operators, which I'll list below for those readers already familiar with bitwise arithmetic. I won't introduce these concepts until chapter 12. Well, let's do it anyways. I mean, so I wonder if I can set that to not show that. Anyways, how long have I been doing this? Anyways, it's only been an hour. Whatever. How many more pages we gotta go? Oh, we got a lot to go. Oh no, we don't. Oh yeah, we got a fair amount to go here. What do we got? 47 to 70. Oh geez. Yeah, okay. We'll do the next one. We'll just keep going. Code bitwise operators .py new, and then we're saying print 9 and 8. Okay, so I don't I understand that this is an AND. I don't know why it evaluates to 8, because it... But he says that he's going to talk about it later. I guess it's evaluating to the highest. Bitwise exclusive or evaluates to 1. Like I don't understand. Print tilde 8. Okay. Bitwise 1's complement flip evaluates to -9. Bitwise left shift evaluates to 8. Print 8. Shift 3. So this would be a bitwise right shift evaluates to 1. And why? Because we have is okay. I think I can explain this. Okay, so we're all talking binary. Right? So 8 is this. So we're talking about no, that's not 8. What am I doing? Yeah. That's 8. Is it not? No. That's 8. Yeah, that's 8. Because that's, this is 2 to the 1, 2 to the 2. This is 2 to the 0, which is equivalent to 1. So that's 8 and 9, which for whatever reason evaluates to 8. And then we have the same problem here. Which evaluates to that. And then if we come to, excuse me, if we come to here, we have an exclusive OR, which I would need the diagram, but an OR gate in Boolean algebra, if input A and input B are equal to 0, are both equal to 0, the output is equal to 0. Otherwise, all other options is equal to 1, is equal to 1. So if A has an input and B does not, or if B has an input and A does not, or if they both have an input, then it equals out to 1. But if an exclusive OR gate flips that so that if it basically says that if A is equal to 1 and B is equal to 1, then the output is 0. So it's if A is 0 and B is 0, then it's 0. If A is 1 and B is 0, the output is 1. And then if A is 0, B is 1, the output is 1. And then if A is 1 and B is 1, then the output is 0. So I don't understand what it's doing, but I get this. This part I also get because we're taking right. Yeah, I'm right. I mean, like that. Yeah, it's an even number, so it's So we're taking this number. I'm writing this down wrong. I'm writing this down wrong. Because 8 in binary is 1 in the 4th position. Right? Because we have 2 to the 1, which evaluates to 1, 2 to the 2, sorry, 2 to the, 2 to, fuck me. Yeah, okay. So this is 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 4, 2 to the 3. 2 to the 3 is that. So then that's 1. And then we're shifting this 1 bit 3 positions to the left, which is then going to equal this. So this is all fucked up. 1, 2, 3. Oops. And so, yeah, this is equal to 9. Right? Because this is 2 to the 0, which is equal to a 1, and then this is 2 to the 8. So all even numbers will always end in a 0, and all odd numbers will always end in a 1. And then, yeah, this makes sense now as well, because we have 1, 2, 3 is equal to 0, 0, 1. Oops. Okay. But he's not going to go into bitwise stuff until later. It also has a binary matrix multiplication, although none of the built-in types support it. If you have a variable that supports this operator, you can use it via x and y. And the related argument assignment also exists. Okay. Sure, let's have a look and see what this does now. Okay. I mean, sure. Fucked if I know. Okay. So now we're doing another one. It's called code math constants dot py. We're going to save. We're going to import math. Okay, and then we're going to say print math.py. And then we're going to say print math.tau. I have no idea what a tau is. It's a float of some kind. Okay. printing pi, printing tau. And we're gonna print math.e. I don't know why I would use Euler's number, but I guess we'll find out what it is and we'll have a quick look and see what it is. Math.infinity. I don't know what it's going to print out for this. God damn. Not a number. And then what are we doing? We're gonna call infinity underscore 1 is equal to a float it doesn't have to be that. And then apparently if we spell print correctly, type in, oops, infinity and that should print true. Okay, let's try this again, or for the first time. Python 6.23. Okay, I have no idea what this tau number is. Give me this is my brain. Tau is a mathematical constant. It's a mathematical constant that is the ratio of a circle's circumference to its radius. This produces a number. That number is always the same. However, the number is rather strange. The number starts and continues without end. Numbers like this are called irrational numbers. Okay. All right. This is, and then, this is standard pi, and then what is Euler's number? It's a number based on natural logarithm. That is an important mathematical constant. The number E is occasionally called Euler's number after the Swiss math, or the Scottish math. It's equally important in mathematics as pi and I. It is an irrational number. Give the first 23 digits. The number is great importance in mathematics as do 1, 0, pi, and I. All 5 of these numbers are important and occur again and again in mathematics. The 5 constants appear in formulation of Euler's identity, like constant pi. Like the constant pi, E is also irrational, cannot be represented as a ratio of integers, and transcendential, not a root of any non-zero polynomial. Okay, but like it is an important mathematical constant. Oh, what's so important about it? It is the base of a natural logarithm. A logarithm tells what exponent is needed in mathematics. Exponential function is a function that grows quicker and quicker. Okay. Right. So it's exponential growth. It's a function that grows quicker and quicker. More precisely, it is a function of something where E is Euler's constant. Okay. And yeah. All right. Sure. Stuff that I don't deal with on a regular basis. This is what I get. Okay. Right, what are we looking at? Surveying height. Yeah. Okay, that was my tangent to go off on. We're gonna clear. And then we are going to code surveying height dot pi. Save. Right. Import math. Distance in freedom units is equal to 65. Hashtag distance to object. I'm going to get a math lesson on this. This is going to be great. I haven't had math in a long time. Computer does it all for me. Angle distance in degrees is equal to 74. And then the angle to the top of the object. So we need to convert degrees to radians. So we got angle dot radian is now equal to math dot radians which is equal to the variable angle degree. And then we need to calculate the object. This is gonna have to be my last one. Unfortunately, my wrists are starting to hurt. Height in feet is equal to distance feet multiplied by math dot tangent of angle in rads. Then we're gonna round to 1 decimal place, which is going to be height in feet is equal to round interesting. Height feet, comma 1, and then we're going to say print height in feet, and it should print out to 226.7. Oh, it's thinking that it's something. I don't know what that did. I think it might have been a color, maybe, because I usually do octal hex in with that. So, okay. Excuse me. Use two functions, radians and math. The round function is built in line here. There can be havens privately erased with floats because of how floating point numbers are stored. You may consider a string format instead. Okay. Yeah, we're going to have to stop there. Well, thank you everybody for listening to my TED Talk here as I go through, start going through chapter 3 of Dead Simple Python, Idiomatic Python for the Impatient Programmer by Jason C. MacDonald. Hopefully I'll be able to get back to this again soon. I'll try to keep putting this up. I mean, this is just mostly for me again, but if it helps anybody, great. Thanks for listening.